Hi guys, welcome back to my channel after a long time. Hope you are doing well. I have a fever, cold. That's why I did not make my video. So let's see. Let's start the metallic bonding today. Look at that. Uh, It is present within the metal. We think that it is present between two metal. That's the wrong thinking, wrong idea. Most of the students are thinking the metallic bonding is present within or between two metals. It's not between two metals. Metallic bonding is present within the metal, within the crystal of the metal. It's called lattice. Look at it. So it is a electrostatic. It is an electrostatic force of attraction between fixed positively fixed positively charged ion, fixed positively fixed positive charged ions and delocalized delocalized electron. So the electrons are delocalized, and it is a it is a an electrostatic force of attraction. Whenever we have the formation of the ions, then we are using the term electrostatic. It creates electricity. So we know that all the metals in any form, like solid state, liquid state, gas state, I'm giving an impression that liquid metals are there, gaseous metals are not present, but they can conduct electricity. Like ionic compound in solid state can't conduct electricity, but the metals can conduct electricity all the time because they have free delocalized electron. So we can also say that a giant lattice, a giant metallic lattice, a metallic giant metallic lattice is also referred to as is also referred to as lattice of fixed positive ions surrounded by surrounded by delocalized or surrounded by sea of electron. So it's just like a sea of electron surrounded by sea of electrons. So the attraction between the positive ions and by the movable electron, it's called the metallic bond. So it's a strong bond, very strong bond. So each positive charge here is surrounded by more than two electrons because the electrons are moving. So please copy down that one. So it is like I will draw the structure, guys. A giant metallic lattice, because it forms a perfect shape. That's why it's called lattice. Is also referred to as a lattice of fixed positive ions. Positive ions are fixed, surrounded by sea of electrons. Okay. Can I rub the boat? Now look at that. Now look at that. Draw the metallic bonding in sodium or magnesium. So we know that this is present within the sodium metal, and is the C of the electron. Positive charges are fixed, Positive charges are fixed. So fixed positive charges, lattice of positive fixed charges, and the sea of electron, delocalized electron. Electrons are moving, and each positive charge is having more than two or more negative charge, which is delocalized electron. So positive charge, fixed positive charge, lattice of fixed positive charge. Positive charges are fixed, and the electrons are delocalized. Electrons are moving, they are not fixed. That's why each positive charge has more than two electrons, which make metallic bond strong force of attraction. Whenever we use the term electrostatic, means it creates electricity, it produces electricity. This is the structure of Na metal. I will draw for magnesium. Please copy down that one. So positive charges are fixed and electrons are delocalized. That's why it creates electricity. So each positive ion has more than two electrons. Okay. Now come to magnesium. Metallic bond in magnesium. Please, I'm keep on telling that it's not between two metals. Metallic bonding is within the metal. It's present within the metal. Metallic bonding within the metal. Very strong bond. We need a lot of energy to break that metallic force of attraction between the positive ions and the electrons. That's why it has highest melting and boiling point. I'm coming to the properties. I want to draw the metallic bonding in magnesium. They will ask you magnesium, sodium, and aluminium. At the most, aluminium. Look at the magnesium one. So fixed lattice structure. It's a lattice structure having fixed positive charge. Magnesium has two plus, guys. You have to draw two positive charge. That's the trick. Two positive, or that's also possible. Two plus. Either put two plus charge or two positive charge. Both are fine. Two positive charge. I want to put two plus. Two plus inside. I want to put two plus inside. Two positive. Sodium lost one electron. Magnesium lost two. Magnesium lose two electron. So two plus, two plus, two plus, two plus, two plus, two plus. For aluminium is three plus. Two plus. Magnesium is in the group 2. That's why it's 2 plus, 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 and the sea of electron. Look at the sea of electron. We have a lot of electrons moving here and there. That's why we use the term delocalized electron. The electrons are not fixed, they are moving, that help to conduct electricity. Okay, now quickly I want to go the properties of metallic bond. First, we know that between the negative charge and the positive charge there is a strong electrostatic force of attraction. That's why we need a lot of energy to break it. So they have high melting point and a boiling point. First, they have high melting point and a boiling point. They have high melting and boiling point. They are the good conductors of heat and electricity. When you heat the metal, all the electrons vibrate and heat transfer. Those electrons, they vibrate first and transfer the heat energy from one place to another place. Hold the spoon Suppose this is the candle and you can hold your spoon here. After some time you can feel the hotness here. That's the spoon. So it means heat transfer from one part of the spoon to the another part, because the positive ions are fixed and the electrons are moving, so heat energy transfer. So they are the good conductors of heat and electricity. They are the good conductors of heat and and electricity. All the metals, all the metal can conduct electricity in the solid form, in the liquid form. Ionic compounds cannot conduct electricity in the solid state because there will be no movement of ions. But here, electrons are moving here and there, which is responsible for the conduction of electricity. Now, two more important properties of the metal. We have lots of properties of metal. I don't want to discuss everything here. Now, two more properties: malleable and ductile. Malleability and ductile. They are malleable and ductile. Malleable and ductile. What what is meant by the term malleable? We can mold them into wires, long wires, copper wires. Ductile, we can turn them into any shape. Metal can form any shape. So they are good for malleability and ductility. Malleable and ductile. These are the important properties of the metals, guys. What are they? Malleability, they are malleable and they are ductile. What is malleability? Mean we can make the metals into long wires. Long wires, change them into long wires, copper wires. All these, the internet, they are passing through the long wires, and ductility into different shapes, into different shapes. We can change the metal into any shapes. Malleable and ductility. So these are the important properties of the metal. They have high melting point, they have high boiling point, they are the good conductors of heat and electricity, malleable and ductility. Now, I want to teach here a giant ionic lattice, because metallic lattice, metal is like a metallic lattice. The repeated unit of a constant shape is called lattice. So after that, I want to teach ionic lattice, especially NaCl. I've seen many questions that comes into the past paper from NaCl structure or CSCl structure. NaCl, we will discuss first NaCl structure. Sodium chloride. Sodium chloride is not a simple molecule, it's a giant ionic lattice. Now, sodium chloride, NaCl, sodium chloride. Ionic compounds form lattice structure easily. Best example, NaCl. They in that case, so ionic lattice. Bonhoeffer is a scientist. He used to work out the lattice enthalpy. I will teach you, guys. When the ions come close together, it form an ionic bond, and that ionic compounds have a perfect shape, symmetry. That symmetry is called a lattice structure, and these units are repeating. So ionic lattice, so they have oppositely charged ions surrounded surrounded by surrounded by different sites by different sites. They have oppositely charged ions surrounded by different sites. So each ion is surrounded by many others oppositely charged ions. We will see the example of NaCl. That's why they have a strong force of attraction, very strong force of attraction. Look at the NaCl. I'm not the artist, guys. I will try to draw the cube. This is the cube. Cube has 6 faces, and at the center we have sodium. So you have sodium here and chlorine, 6 chlorine. So each Na plus in NaCl lattice, each Na plus is surrounded by 6 Cl minus and vice versa, because one more unit repeats here, one more unit repeats here. That's my sodium. We have a big structure for chlorine. Chlorine is the bigger atom. So we have chlorine here. We have one more chlorine at the corner, one more chlorine. So we have 6 chlorine, one more chlorine at that side. So one more chlorine, one more chlorine. So we have 6 chlorine because each cube has a 6 faces, and each Cl minus is surrounded by 6 Na plus, because we have one more unit here, one more unit here, one more unit. It's very large, it's very big unit. You can easily see this model in your lab or in your laboratory. So NaCl is a perfect giant ionic lattice. So each Na plus is surrounded by 6 Cl minus. They have oppositely charged ion surrounded by different sites. That's why it has a very strong force of attraction. One more question. Can a solid NaCl conduct electricity? No. Only when the NaCl is in the molten form or in the aqueous form, then only it can conduct electricity. My question is that why solid or lattice, not the solid, my bad, why the lattice NaCl do not conduct electricity? Simple reason, because the ions are not free to move. So it is called, actually, that is called the phase center cubic, but don't worry about it. So we have cesium chloride also. Cesium chloride, each cesium is surrounded by 8 Cl minus. Here each sodium is surrounded by 6 Cl minus. That was a past paper question. So guys, please do the revision on all the ionic bonding or the chemical bonding. You can watch my videos. I just want to teach one more topic in the series of the bonding, that is giant covalent molecule. I didn't teach you the giant covalent molecule. Then after that, I want to compare the properties of the ionic, metallic, giant ionic, giant covalent, simple covalent. Thanks for watching my videos.